For problems 2 through 4, we're going to sketch rough graphs of the following polynomial functions. What we're going to do is take the factored form equation to find the x-intercepts. We're going to plot the x-intercepts and use what else we know about the orientation and about repeated roots to draw a rough sketch. We did do this in lesson 8.1.2, so this is going to be pretty similar to that. Problem 2, we've got y equals negative x times x plus 3 times x minus 1. If we use the zero product property to find our x-intercepts, we're going to get 0, negative 3, and 1. And again, the reason that I'm getting the same numbers but opposite signs when I'm going from my equation to my roots is because if you use the zero product property, let's say, and you take each factor, set it equal to 0, I'm setting x minus 1 equal to 0 as an example, I am going to get that number but the opposite sign as my solution for x. Okay, that's why we have the opposite signs. So my x-intercepts for graph 2 are at 0, negative 3, and 1. I'm just going to scale my x-axis because, again, this is a pretty rough sketch. Okay, we'll plot our intercepts. There they are. What else do we know about this graph based on the equation? Well, there's a negative, which means that this graph has a negative orientation. And what that means is that as my graph moves to the right, the graph is going to point downward. So from the last x-intercept right here at 1, 0, my graph is going to point downward, right? That negative orientation. And then the roots are not repeated, so we don't have to worry about the graph bouncing off of the x-axis or flattening at the x-axis. This graph is just going to go right through the x-axis at the 3 intercepts that we see here. So backtracking a little bit, we're going to go through x equals 1, then back down through 0, then back up through negative 3, 0, and that is approximately what our graph is going to look like. Let me do that with the pen instead of the highlighter tool. Okay, that might be a little bit better. Okay, there's a rough graph for number 2. For number 3, we've got y equals x plus 1 squared times x minus 4. Again, using the zero product property, we can find our x-intercepts, aka our roots. Those are going to be at negative 1 and positive 4. Negative 1 is a double root because x plus 1 is squared. So we have to be conscious of the fact that at negative 1 on the x-axis, we're going to have to bounce off. Okay, those are my axes. I've just scaled the x-axis. We'll plot our intercepts. Okay, this equation is positive. There's no negative sign, so we'll assume that this graph has a positive orientation, which means the graph is going to point upward as we're moving to the right. Now backtracking, this graph is going to go straight through the x-axis at 4 because that's a single root. But then as we're going up to touch the x-axis at negative 1, this is going to bounce right off. Again, bouncing off because this is a double root, and that's what happens at double roots. Okay, there's a rough graph for number 3. Last but not least on this slide, we've got number 4. Y equals x minus 2 times x plus 5 cubed. Our x-intercepts are at positive 2 and negative 5. Because x plus 5 is being cubed, the negative 5 is a triple root. A reminder that at triple roots, the graph flattens out on the x-axis. Okay, let's draw our axes, scale the x-axis. Okay, just like with number 3, number 4, number 4's equation is positive. This is going to have a positive orientation. And also like number 3, if I'm backtracking, the 2 here, that last x-intercept is a single root, so the graph is just going to go right through the x-axis at that point. But as we're coming up to intersect the x-axis at negative 5, remember that we are going to flatten out. Okay, a little hard to see, but we are flattening out on the x-axis right there at negative 5. Okay, and that's it for these problems.